welcome to Race Industry Now, the weekly webinar series from ePartrade, presented to you by ARP, Performance Plus Global Logistics, Feria, Peak, Fifth Third Bank Motorsport, Quarer, and CTEC Manufacturing. I am Francisque Savignan, the founder and CEO of ePartrade, the racing industry, every minute, every day. This is the first episode of the 2025 season, and we're going to be live every Wednesday until the end of October with an amazing lineup of speakers. This is also episode 532 of the entire series that started back in 2020. So with me this morning are Judy Kin, the co-founder of ePartrade, and the one and only Mr. Jeff Hammond. Judy?
Thank you, Francisque, and thank you everyone for joining today with your time and attention. We appreciate that. It's an exciting season ahead. And I just wanted to remind people, because we have so many new people joining us today, we took our 100+ years of trade show experience, combined that with today's technology, and created a performance and racing destination. We have suppliers showcasing, similar to exhibitors, or like exhibiting at shows, and now buyers could reach out to them, see their latest products, reach out to them, post RFPs. So we really made an interactive platform for the industry to use. So please feel free to sign in, use it. That's why we created it, and help us spread the word. Thank you. Jeff?
Good morning, both you, Judy, and Francis. And thank you for bringing me back another year. It's been a lot of fun being associated with this group, watching it grow, watching how the benefits of the ePartrade and the platform, how it works, and it's helped so many people do a better job more efficiently. And all my years of being around the sport, I've always said it, 365 days a year, 24 hours a day. I mean, that's what makes this place so special and this company so unique unto itself. So I'm really excited about, again, being a part of it, but also bringing back a company that we've had on before and realize that there's people that have found the product, they're excited about the product, and Line2Line is definitely, one of the family products I would consider here in ePartrade. So I look forward to this season, along with my buddy Brad Gilly, and get the chance to host this every Wednesday, or every other Wednesday, I should say. I want to do it every Wednesday, but I got to share it with Brad.
Absolutely, and you're a big part of the success of this series, Jeff. Thank you. And today is very special because we have Line2Line Coatings with us again, bringing a special guest, Mr. Jon Kaase, which, by the way, was our first ever guest on the webinar series. So back in 2020, when we had our first webinar with Jon, we had never done a webinar before. Jon had never done one before. And Lake Speed got us together. We made it happen, and we thought we should do a few more. And this is episode 532. So thank you, Jon. You helped us a lot in doing this. And of course, thank you, Andy and Brian, for being with us today and share your expertise on coding. So Jeff, on to you.
All right. Thank you very much. Good morning, gentlemen. Good morning, Andy and Jon. And I guess we're waiting here for just a second on Brian to join us. And guys, I'm very interested in what you guys are going to share with us today, because I feel like we have got a product here that has, I think, revolutionized a lot of the industry in a lot of different ways. And Andy, you and I were talking yesterday. Why don't you kind of lead us out and give us an idea, because again, you've been on before, but yet just like everything in racing and manufacturing, technology has moved us along quite a bit in a year's time.
Thanks, Jeff. I'm going to start up I got a couple of slides to introduce kind of what the coating is for those who aren't familiar. So can you see it?
Not yet.
Okay, I guess my screen is not shared then.
Well, come on now, share with us. That's what we want to do. You and I talked about this yesterday. Just
yeah, I didn't
process
know.
And we'll get it right.
Do I hit the share screen? I thought they did. Okay, so now we'll try it again. Okay.
There we go. We can rock and roll now.
There we go. So thanks a lot, John and Brian, for spending some time with us. Really appreciate it. Looking forward to the main part of this program is supposed to be you guys sharing your real world experience with our coatings. So we appreciate it. So basically, what does our coating do for engines? Does a couple of things. One is it makes the piston fit better in the bore. And the other is it improves the oiling and the hydrodynamic regime of the lubrication of the pistons. So in the abradable, in the term abradable coatings, means we're gonna build it too tight. Wherever it starves of oil and gets too tight as things heat up and run, it's gonna wear off gradually some graphite. And it's a safe process. And when the piston is run long enough, it actually achieves a shape where the oil film can get back in there, and then the wear stops. So we're effectively taking up extra clearance volume between the piston skirt and the bore, and that clearance that we're occupying with the coating, that's where all the pistons can move around in all different modes and harmonics. And if your piston is rocking and flopping around and vibrating, so are your rings. So your rings have to keep resetting constantly if the piston is moving. And so if we just take up some of that clearance, there's less room to move, the piston works better and the rings work better. And you see that through a lot of modes, power, sealing, pan vacuum, blow by, and wear. You can see wear modes disappear. So on the oiling side, we make a bigger footprint of the skirt on the bore. And the oil film gets thinner, so you're not sloshing around oil that never carries a load. There's friction in that oil that never carries a load. And so if we squeeze that out and make a thin oil film, it's just harder for the piston to actually break through the oil film and touch. That's called boundary lubrication, and that's where you get friction and scratches. So in a nutshell, we stumbled into a way to make more power and longer life in combustion engines and even compressors too. So a couple of little graphs that help you see. This is an example on the left side. It's a fuzzy coating. It feels kind of like velvet or velour when it's freshly applied. And then you build your engine too tight, real quick, it knocks those peaks off. And after a full break-in, when the oil film forms, you end up with these super polished plateaus that I'm zooming around, the light gray on this picture here. And then notice you've got these randomly linked pockets for oil. So you've got thousands of oil wedges on your piston skirt instead of one big sloshy one that fails. So the way we achieve that is some smart guys, Mr. Strybeck and Mr. Hutchings. They both did a lot of work. This is the Strybeck curve down here. It shows oil film thickness relative to the roughness of your surfaces. So if you have a very low oil film compared to your roughness, your asperities can touch and you see this friction is climbing really high. Up here, you're going to seize or scuff. Out here on the other side, you've got tons of surplus oil and your parts never really touch, but you can see again, the friction is rising as we go to the right. That's because you're stirring a bunch of oil that really doesn't need to be there. So the trick with abradables is we build the skirts too tight. When the piston heats into the bore, we know it's not going to fit. And that's when you start knocking off the graphite quickly. So you keep running, and as your wear rate declines and your friction declines, things get better and better. The piston is finding the fit that it wants to be in each bore. And down here at the end, you can see in the green box, the wear stops now because you've got no contact between your piston and your bore, and you end up in this low friction area, and all the extra space that would have been over here is now occupied with the coating. So that stabilizes your piston and the bore, and again, the rings. So it's a really neat process. Once it's done, those little plateaus are polished, and it only takes a tiny film of oil, probably microns, to fully lubricate each of those little oil wedges. So the other thing, you know, as that's happening, it happens in every location on the skirt. You can see some areas will get turned shiny where it really burnishes in. If you get around to the sides, there's still fuzz left. So that fuzz can carry the oil film and transfer load and guidance, but it doesn't really need to wear a lot. So we like to see full engagement of the skirt, and that way we know we're holding that ring and piston assembly as straight as we can. So this is basically on the left, your regular profile with a cam and profile where you know, maybe the middle of the skirt touches, you start to see some scratches in there. Oops, went the wrong way, clicked it. But on the Abradable, like I just showed you, you get a big area with the ideal oil film. So that's your low friction and guidance. Here's another piston. This is one Brian sent us a picture just a month or so ago of a stroker engine. You can see where it's coming out of the bore. You can see some fuzz up here on the left, and on the right, that part's not engaged real well, but it's still stabilizing. But a lot of that piston is, a lot of that skirt is doing the work of guiding the piston. So back to the guidance, you know, if there's a bunch of clearance here, we call it integrated skirt clearance. Another, maybe a better term, is skirt clearance volume, because everybody measures one spot or two spots in the skirt and they go, that's our clearance. Well, what if you go 30 degrees around, or what if you go above or below that? So we want to take up clearance in the whole area of the skirt, and that's what's going to guide your piston. And again, if it's too tight somewhere, a little more graphite will come off. So that's the self-fitting. But if you keep your rings square to the bore and a full hydrodynamic lube regime on your skirts, everything runs better, lasts longer, lower friction, less noise, and other good stuff. Here's one I love to show. This is an Outlaw 358 piston. It's a really high-end engine builder. You see this area that is kind of worn through the coating. He was scuffing pistons with a new piston design. Very nervous watching his cars on the track. And we coated some, the problem went away, and we figured out that, hey, this piston has a heavy fillet behind the skirt right here. So the flexible part of the skirt was able to move away. That created kind of an edge at the edge of that fillet, which was scraping the oil, and then he was scuffing pistons. So you can see that, you know, the hot spot is worn away. The coating will go away if it has to, but wherever there's room for it to exist, it will support the oil film. So just a neat example. So we have a few locations. Brian on the call today is down in South Carolina. We're in Michigan at headquarters in Line2Line. Chris Borowick is out in Nevada serving the West Coast, and United Engine and Machine offers our coatings on their products. So if you have someone else's pistons, you got to send it to one of us three. If you're buying UEM pistons, you can ask them to apply it in a custom fashion. We're also kicking off a guy, great guy, Russ Pavey in Australia. A lot of racing down there, so he is just about turning on right now. Took a lot longer than we thought, but he's up and running. So here's a car John built the engine, and they're in the winner's circle. So Johnny Plucino, I'm not sure if he won the title that year, but John's all over the track with champions, and we're really pleased that Brian got us in there for him to use our products. And that's all I got. Oh, one other thing, pretty neat. If I stop sharing, I guess this will shrink. And then I wanted to just show, this is a piston that a friend of mine lent me for this. This is an original P51 piston out of a World War II vintage motor, Rolls-Royce Merlin engine, supercharged. So you got the dome, the dish up there. Just imagine machining this thing. 2618 was invented as an alloy for that engine platform. So this helped save the world right here. Pistons catch all the power that you need to do what you're going to do. But look at all these intricate holes. They're all in different angles, and they did it all by hand. It blows my mind. So anyway, that's all I got. And thanks again for joining us.
Well, Andy, appreciate that little introduction right there. Brian, good morning, sir. How are you?
Good, Jeff. How are you?
Well, now that you're here, I feel a little bit more relieved because you were an intricate part along with John here. We wanted to get an opportunity to get you two guys to talk about, the practical application and everything. And I really appreciate John taking time for his busy schedule to, I know this is kind of like the early part of the year, and a lot of times there's a lot of racers that are looking for parts and pieces and for their engines and trying to get ready to go to the racetrack. So, and doing testing. So I know that time is very important. So I'd love for you two guys to take what Andy has kind of basically, laid out here in front of us, and tell us a little bit about the practical application. And John, I guess the biggest question has got to be, why did you decide to go with this line-to-line coating that these guys have come up with, and what have you found that's done as far as the benefits to your product?
Well, it's kind of one of those deals that we really started off probably about 7 years ago. We all went to dinner at the PRI show, and the guys there, they were explaining to me the coding and all that, and I think I was kind of born skeptical. So, I said, well, all right, we'll look into that. You know what I mean?
Hey,
But
John, let me do you a favor, right? Let me do something. These guys have got to be full of it. They ain't no way they can do this kind of stuff. What do you think they're trying to sell me? Some kind of magic fairy dust?
right,
Am I
right.
wrong?
It's a snake oil, but
Yeah.
it came up to it was time to try something from them. At the time we were getting pistons coated different places. Some of them came from the manufacturer that way, but I liked the idea of it. If it would work, it sounded really good to me. So nothing to do but try it. Um, we we have kind of a situation with the big engines, and I've got a couple things here I was going to show you if you can see them. But the on the big engines we built, for one, the piston sees a lot of speed. I don't know if there's anything sees like our piston speed is like 8,400 feet per. I don't know if it's an average or something, but I know the number is 8,400 something, and that's more than a really high RPM smaller engine, because it's got a 5 3/4 stroke, and we run them 85, 8,600 RPM. So they're really grinding away in there. And but the biggest problem we have, other than speed, is that because of the big stroke and you have an aluminum rod and everything, you end up with a really big window at the bottom of the bore where the rod swings through. And on every one of the sleeves, there's a spot where the rod swings back and forth, and then the other one across from it, the bolt comes by, and you have a really big, huge cut in there. So when the piston gets to the bottom, it's not very happy. There's not much holding it in, and so I'm gonna see if this. I know when he held that piston up before, it looked good, but see, this is a sleeve out of a working engine. The only thing really wrong with it was it got too big, and the cubic inches were right on the limit. So we put all new sleeves in it, cut the bore down, 10,000. So it was back to being super, super legal. But see how big this cut is right here, and it doesn't look bad. But here's the piston. This is what a piston would look like uncoated, but where the red line is, the only thing left in there is these little areas like right here. That pretty much is the only thing holding that piston from doing this at the bottom. And even though it's at the bottom and it's not, you think, well, one of the valves is always open when it's at the bottom and it's not making power. Well, it is, believe me, and anyway, so it's, it sits in there like it comes out that far, out the bottom, and there's nothing much holding it in. So it almost exposes the oil ring right here. So, the tighter you can make it down there, just the better. Everything's better if it's not bouncing around. But we started coating those pistons, and we started them tight. And our normal deal, what we've pretty much settled down on, is about 2/1000 clearance, which that's pretty tight for a big engine, for a 4.800 bore. They would normally be starting at probably 8, and these only start at 2. And we found that after they run, the piston crushes a little bit. It actually loses some size. It'll lose a couple thou, and the coating will wear a little bit. But we've had engines, we take them apart every 30 runs because we have to put a connecting rod in them. 30 runs is about it on an aluminum rod. So we take them apart and we measure all that stuff, and we found on the best of the pistons and all, they'll end up about 6/1000 clearance. So it may have pushed the piston in a little bit, just the aluminum itself, and then it's worn a little bit of the coating off. But it seems like 6 is the number. But there's a couple other things you got to look at though. We can put them together at 2/1000 with the coating, but what you wouldn't want to do is put it together with 2/1000 clearance, but the piston was only 4/1000 smaller than the bore, if you know what I mean, because all of a sudden you'd wear the coating off and you'd be on the aluminum, and then it's not going to work at that. It'll either cost you a whole bunch of power or it'll burn up. So you have to have a thick enough coating, so when it does wear off, it gets you the clearance you want. So on a normal deal, they pretty much set most of this stuff up. If you tell them you want a piston for a 4800 bore, it'll come in at 4.793 or something. It'll be set up for 7 or 8/1000 clearance, and then we'll have Brian coat them till they're about 2 or 3/1000 clearance. And then when we run them, it's a little scary because it doesn't hurt anything. But the first couple of dyno pulls, you're wanting to jump off a cliff. I'm telling you, they're 100 horsepower off of where it should be. And then the next run, it'll be 50 off. And then the next run, it'll be 20 off. And then all of a sudden, it's where it should be. But at least when it does that, that the surface of the skirt is the arc that it wants. Because if it takes more off the middle, well, that's what it wanted. If it takes more off the outside edges, it was happy with that. And then at that point they'll run a long time. We'll run a set of pistons for a whole year, maybe 100 runs, and we'll put 3 sets of rods through the motor, and we won't touch a piston again. So they take a lot of abuse on these big engines, because they're 2,000 horse motors, and they'll do just fine. I had like. This is one of John DeFlorian's. It's Pro Stock piston, and you can see the skirt on. It looks pretty good. You don't see an aluminum anywhere. This one's 3 years old. I don't know how many runs it has on. But then I dug around on my trailer outside because we haven't had anything that wasn't coated by Line2Line in the last 6 or 7 years. But I found an older engine out there, and it's got, you can see where it broke through the coating. That was just a different style of coating from a different company. I mean, it didn't fail, but it's not right. And that's just typical of what we see.
Okay, I got to jump in here right quick because I'm sitting here and I'm looking at Brian, and Brian's grinning, listening to you talk and explain all this. But for the two of you guys, how nerve-wracking is it? I mean, I feel it, but at the same time, how long did it take for you to build this kind of confidence in this program? Because again, you saying like, okay, it's routine now, but at
Yeah.
that point in time, I mean, the first time that you sized it and everything, Brian sitting there saying it's going to be okay. It's going to be
Well,
okay. Just stay with
I,
me. How many testing and what kind of procedure did you go through before you hammered down on how many $1,000 engine that you were getting ready to run? I mean, did you guys set up a like a dummy run, with this having it cycle, just running in the piston cold, you know what I'm talking about? I know
yeah.
you guys just didn't build this some gun and hammer down on the first time.
Actually, actually, I'm a lot more brave than some because we almost did that. But
Okay.
we'll just make, a dyno pull on one of these engines is only 2 seconds long. It goes from 7,000 to 8,200 or something, and it goes at 600 RPM a second. So it's only a couple seconds. So
A lot of things can happen in a couple of seconds.
yeah, you can be about 50 grand lighter in the pocket, but
Exactly. Exactly.
but we would normally back the timing off a bit, and then we'll make a run that only goes to 7,500. Maybe it's only 1 second, and then we'll kind of cool it down a little bit, and then we'll go a little farther. And honestly, we don't do it like you're supposed to do it. You're supposed to cool it off and go to lunch and come back, all this stuff. No, we just beat on it, and it works okay. But we haven't ever really had anything that made it like, oh, I shouldn't have done that. It kind of wears it off pretty good initially and wears it down to the shape it should be. And then from then on, it seems like it just kind of stays. But we don't go to the break-in all this hocus pocus as much as we should probably, but I mean it works fine. So I think that the one thing that does bother you is the first couple of runs. If you start with it tight, the first couple of runs it doesn't make near the power. You know. Now we had one we did the other day that was more like 5,000 clearance instead of 3, and about the second run it was making pretty good power by then. So there's a kind of a line there where it's not going to make any power till it gets to a certain clearance because it's just too tight. But the plus side is the vacuum is really good in the crankcase, and that's especially on a big engine. That means a lot because you lighten up the atmosphere in there, and it's the crank's running around at 20,000 feet instead of sea level. The air is lighter, and it's the vacuum's probably worth 30, 40 horse at 8,000 RPM on a big engine like that. So if it makes a little more vacuum, it'll generally make a little more power, especially if the reason it made more vacuum was because the motor was happier. You could put more vacuum pump on it or something, and it makes more vacuum, and it might not be a whole lot more power. But if it's making good vacuum because it's like some of the stuff we have doesn't even have a vacuum pump anymore. It's just got a big oil pump, and that's all. And they'll make 22 inches or so of vacuum in the crankcase. And an engine that big, I couldn't ask for any more.
So Brian, what is it like from your side, representing Line2Line when you've got people like Jon coming to you now and wanting to understand this process better because they've heard about it and they understand that this is the future. So how do you make sure you build that confidence that you have now? I mean, it sounds to me like that Jon's ready to walk through fire for you and your product. So I mean, it can't be just like he said, an easy sell. Let's put it that way.
So let me back up a little bit. When I first came on board with Line2Line,
Mm-hmm.
I was running a 10.5 Outlaw car, and actually we had a 706 in it that was built for one stage and for another class. You could only run one stage of nitrous on that car. Well, we ended up putting 4 stages on it because they needed some more cars around here, to run that class. Well, I had 3mm oil rings on the thing. And so, when you put a big stage of nitrous on it, as soon as the nitrous came on, the pan vac would just disappear off the race pack graph, you know. So I met Andy and Mark at the PRI when it was in Orlando, and we got to talking, and basically they'd never coated a nitrous motor before. And I said, well, hell, I've got mine apart. I said, you know, I'll send them to you. Well, they coated them up, and I put it together, sat on projects all winter. First race out, I really kind of forgot about it. You guys talking about the snake oil. So we go out there the first qualifying pass, and I'm just used to my pan vac just dropping, you know, straight off the bottom of the screen. We make our first pass. Car ran pretty good. The graph for the pan vac went all the way to the other side, which was a first, you know. And I'm like, what in the hell is that? You know, well, anyway, I got to zooming in. I said, man, what's going on here? I've got vacuum all the way across the run. Then it dawned on me, well, hell, all I did different was put line to line on the pistons, right? So in the course of that weekend, we picked up 1/10 and a half and 7 mile an hour just tuning on that line, because I could zero in on that race pack. I could tell when the motor was detonating, and, you know, when it needed timing took out or fuel took out or added. So we qualified number one and won the race. And that's when I knew that it was the real deal. Coming back to your question, Jeff. So I already had that in my pocket now because of my experience. I knew this wasn't snake oil or fairy dust. So when I went to talk to folks like John, Gene, Pat Musey, you know, guys that, you know, you better have your crap together when you talk to them, because they're not going to give you the time of day. And so it allowed me to have that confidence and know, you know, from my own engine, what I was dealing with, and, you know, and how the stuff worked. So I hope in a roundabout way that answered your question.
No, I mean, because again, you know, I've been fortunate enough, you know, being in the business, you know, my side of the equation with stock cars and stuff. But you know, there's horsepower in everything you guys talk about, and coating was one of those big finds for, you know, for NASCAR engines and short track engines. I mean, whatever principles exist and any kind of racing that we're affiliated with, is a constant. Am I wrong about that, John? I mean, you know, the principles are there, you know, and Brian, and again, if you can reduce friction and seal up the engine. I mean, everybody always talks about sealing up and making sure all this stuff fits the best it can. You usually have an instant success. I mean, you pick up something somewhere, you know, and then like you pointed out, you all of a sudden had a target to go to work and fix, you know, timing and fuel, and, you know, and I mean, anything you can do to help tune in areas that you have never had experience with has got to be, again, a plus for people who understand the principle.
So that engine was a Brodix cast aluminum block. Like, it wasn't billet. It wasn't, you know, like what a lot of the guys race with these days. And so that thing just beat up parts. The pistons, you know, we was putting, you know, half a rack of pistons in it whenever we was changing the rings, you know, but the stability from the coating, you know, and taking up that secondary motion, man, it was a game changer for us. You know, the pin bores weren't beat all up. You know, the pistons weren't slapping around. The ring stays square to the bore, you know, and man, even tuning, you know, I grew up spark plug tuning. I didn't have these race packs till I finally landed a sponsor, you know, and but you know, I was always just looking at the plugs to read the fuel ring and the timing on them, and it was a completely different engine, you know, when we coated them. And so I knew right off that this was some great stuff. And I was, I was a lead engine builder at PAR for Scott Duggins, the better part of 20 years. So we had tons of sportsman racers that, every year they'd bring their motors down for a freshen up, and basically, it was hone it 5 thousandths and put a new rack of pistons in it. Well, now, we could hone it just to clean it up 2 or 3 thousandths, coat the pistons, and that engine was out the door in 2 or 3 weeks. It was a game changer, all the way around. And this is before I was really, became Line2Line Southeast. So still in awe every day.
Well, guys, we're getting a few questions and comments, and some of them are this, you guys are the best in the business, but Jim's got one here, and John, I'd like to kind of go back to what we were discussing, and you were talking about how you break engines in, but he was wondering if you're breaking in an engine with a new flat tappet cam, does the break-in process change since you're shedding this abradable coating into the oil?
We've not actually done that, but I don't think it would be a problem. Breaking in a flat tap is probably one of the most miserable jobs on earth, and it's scary because it doesn't always work. But I don't think it would be any issue for the pistons whatsoever, because you're part throttle and you're not really revved up. I don't see what would be a problem. But one thing I was thinking about, if I could add here, was there's a couple things about the coating that and I keep telling Brian, I said, Brian, you don't realize how much money you saved me, because he just mentioned it a minute ago. But we'll send, we'll hone the block a few thou or something, and I get a block straightened out, and we'll send him the pistons back, and we'll have him, he'll blast the coating off, and he'll coat them again and coat them thicker, and then there's nothing really wrong with a piston. It's just not the right size anymore. And so, we can save a set of pistons by adding material to it. And and these pistons, some of them cost $3,000 a set. Okay. So if you got 1/10 the price or something of coating them, yeah, why not? And then there's one other thing when I thought about when he talked about the flat tapping, um, which we don't have that much trouble here. But if you have an engine that ever hurts a lifter or it hurts a rod bearing, it throws all that crap up on the piston skirts. And if the pistons are still usable, other than the skirt looks like hell, um, unless it's really removed a lot of metal, if it's just all scratched up, like oh, like this one right here, it's kind of scratched a little bit. It's got some stuff embedded in it, little pieces of metal that are stuck in the skirt. And so they give them a little blast with some sort of media, and all that stuff comes out of the skirt. And then when they recoat it, the skirt looks like new. And even if it's got some grooves or voids in it or something that were noticeable, it doesn't really matter, because it's not going to be, there's nothing sticking out. You might have a couple scratches here and there, but it's full of coating. It doesn't really know it doesn't know it's not new when you get it back. So, we've saved a lot of money in doing nothing but making the pistons bigger, and we've saved a lot of money by taking pistons that were in an engine that had an accident, and we made them look like new again, and we didn't have to wait for, and plus the thousands of dollars, because man, I'm telling you, this engine parts anymore have got to the point that, you know, if you have a set of pistons like on any one of these big engines, if you have a new set of pistons and rods with the rings and the bearings and everything sitting on the workbench, that 8 pistons and rods probably cost more than the house I grew up in.
Wow.
Pretty close.
Hey,
That's stupid money. So
no,
if you can save
you're
it, and
right.
there's no downside to saving it if the last piston's not hurt. It's just it's not the right size or the finish on the skirt. They can fix both of those.
And Andy, real quick, I want to bring you back in here because again, that one question about the particles and stuff, you know, you're the mad scientist, that had a lot to do with, coming up with this coating. So, is there any harm whenever people get this and they're running it? Is they got to be fearful that as soon as you run it and it breaks in a little bit, you got to change the oil? What kind of process is there that you would recommend, first time folks that, try your product?
Yeah, we've never heard of any problems with the particles coagulating anywhere, getting behind bearings or anything. One thing that the coating needs a little bit of friction to wear in. So if you start off with super synthetic oil, it may take longer to break in.
Mhm.
Also, if you have a super polished bore, some of or not polished, but with the plateau honing and they keep going finer and finer for friction, that can make it take longer to wear in. So with the tappets and that kind of thing, it's never hurt anything. And if you think about it, some of the assembly lubes have particles in it, moly or probably Teflons or whatever. And yeah, so these little tiny particles of graphite and plastic function like those particles in assembly lube. But no, you can break in an engine and run that oil to the full length of the oil's life, and it will look dark, but there's nothing wrong with it.
Again, it's like, I don't know how you explain it to somebody, is that, the magic that this product gives you, and everybody, that's been involved in racing in recent years understands that coatings are an important part of a lot of things we do, and to hear it from, guys who have took the chance on it when it was in its infancy and have gone through the process. I mean, it's fun to listen to you guys talk about it, because you see, with Brian, the excitement that was created because he knew that the only thing he did was the coding. And the same way with you, Jon, is be able to sit there and listen to you talk about how your benefit is you're saving your customer money, because the ability to maintain and put pistons back in an engine that a lot of times would wound up, in a garbage can. I think that's something that's refreshing, is that you got a product that keeps on giving, not just one time you use it and then throw it away.
It's really nice when you have an engine that's scarred up, like I said, and you had a lifter bearing failure or something, and throw that trash on the skirt. And it's like it's usually two or three pistons at least. Sometimes it could be all of them, but usually it's the ones closest to the bad lifter. And there'll be just lines in them, and it just makes you want to vomit, looking at it. I've sent those off and got them back, and you couldn't tell them from a new one. And after they ran, you couldn't tell from a new one. And you could probably glass bead them and sand on them yourself, but they still wouldn't be like they are when you coat them. So I mean, that's a huge gain, that it just saves you a lot of time and money. And sometimes, it's the time. I mean, if you don't have spare pistons, and none of those people want to make two pistons, I don't blame them. So, it's hard to, you can't call a company up and expect them to just stop everything and make you two pistons, you know? So,
Right.
we've saved a lot of engines with that.
Well, when you say something like that, okay, is it applicable to two cycle engines, um, I mean, anything as far as, four wheelers or anything like that, I mean, wouldn't it be? I mean, we keep talking about all this stuff being kind of like, it works in all forms of engines, period. Is that right?
Yes, sir. It's Mike Wienant. He's a two-stroke engine builder, does a lot of work. He'll move ports around, and he's got the software for the flame front and all that stuff. He'll move his spark plugs around and do all this stuff on the computer for 2 months before he cuts any metal. And he goes into a class and wins, and he will not build a two-stroke engine without our coating. It's also in in some drones that burn heavy fuel at 30,000 feet. So there's a lot of thermal concerns. And so, yeah, we're in a couple different drone programs. And, you know, that's a boosted two-stroke environment. And they want those things to run efficiently as long as they can, you know, because it costs a lot of money to get your 20-hour mission is a lot longer time for that engine. If we can get it to 25 or 30, all else the same, it's a huge benefit. So yeah, the two strokes, the transfer stroke, you know, as it's coming down, once the exhaust port opens, I believe the ring gets loose. There's no compression anymore. So then you got a floppy piston and a floppy ring trying to transfer the fuel to the top. And if you seal the entire side of that skirt instead of just with the ring, you get a much better transfer. So your power band comes down to a lower RPM, and they're just poppy, so loud. You know, you go, I'm going to go watch some little two strokes. They'll blow your ears right out. It's amazing. And you can hear the difference of a floppy piston really well, like in a dirt bike. So yeah, and you know, all the other stuff too with the ring stability and minimizing wear, that all plays in too.
What's
You know,
funny
I know
about
we're getting
that?
close to the end of our session here, but I got to go back to that P51 piston that you showed us a moment ago. You doing coatings for those guys? Because I mean, you know, working for Jack Roush, you know, Jack's a big vintage aircraft guy, and he did a lot to, you know, make make stuff that you could reproduce. The FAA would approve for vintage aircraft like that right there. So I'm sitting there thinking, I said, I wonder if we're coating those pistons yet on that. I mean, that's another application that somebody needs to take a look at, because I know Jack talked about how expensive, because you just don't go down to the corner store and pick up a piston for a Rolls-Royce airplane engine.
Right. We actually Delta Hawk is making a like a small engine that would go in Cessnas and stuff, and we are qualified by the FAA on their engine platform, and they're going to be able to burn diesel fuel instead of aviation fuel. So you save. Those things climb higher and have a longer range than you know the aviation fuel. We've done Allison engines, but they're on tractors for tractor pulling, you know, these huge pistons, cool stuff. 1906
like a 5-gallon bucket.
Yeah, a lot of vintage stuff. It's really neat.
Yeah.
Old fire trucks. We did a 1906 Cadillac single cylinder piston, a clunker about that big. And it's just really neat. These guys are like, man, I got my unobtainium is working perfect now. So we have a ton of fun with the old stuff and the new.
Yeah. Well, Andy, John, Brian, thank you. Again, you know, it's always entertaining, and I mean this in a professional manner, to hear people talk about coming up with something that's working, it's applicable, it's improving the overall industry. Thank you for that. Thank you for sharing it here with us on the Par Trade on Wednesday at the beginning of our 2025 season. And thank you for your time, gentlemen. Francis, I think we have been blessed. You and Judy both. You picked a good winner here today.
Absolutely. Thank you so much. This webinar has been recorded. It will be posted later on the Portrait platform, distributed through our newsletter and social media channel. Don't forget to check the Portrait platform. We push the line-to-line coatings back to the home page. Next week, we will be talking chassis setup with Laba 7. So once again, thank you and goodbye.
Thanks for having us.
Thank you.
Thank y'all.
ePartrade is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePartrade, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, All you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
ePartrade really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series. Where can we take your business? Fifth Third Bank.
Where will you find Ferrea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Ferrea Racing Components. Stand with us or race against us.
When it comes to pushing the limits of performance, the pros know there's no room for compromise. At Crowder Cams, we don't just engineer camshafts and valve train components, we redefine what power means. Since 1955, Crowder Cams has been the name trusted by racers, engine builders, and gearheads around the globe. Whether you're building a street machine, a dragster, or a track car, Crowder Cams provides the muscle you need to dominate. And with Crowder, victory is within your reach.
For over 25 years, Wisconsin-based C-Tech Manufacturing has been engineering and manufacturing the toughest, most accessible aluminum tool drawers, cabinets, carts, and tactical storage solutions for America's hardest working professionals. Whatever you need to store and however you need to store it, put your trust in C-Tech Manufacturing. We build it better. Visit our new website at ctechmanufacturing.com or give us a call at 715-355-8842.